Okay, let's take a look at a couple of examples where we want to simplify or otherwise rewrite some sort of expression, and in doing so we're going to have to evaluate a function at a particular input value. Okay, so for example, number one, let's assume the function in question is f of x and it's defined by x squared plus 3, and then I want to look at several different expressions here. I want to find what is f of 3, or what is f of some unknown a, or what is f of some sum of an unknown a and h. What is f of x plus h? And finally, what is f of x plus some delta x, we'll treat that as one unknown variable there, minus f of x, all of that over, again, delta x. This one looks kind of complicated, but it turns out we actually will see this many times in calculus. So let's go back up to the top here. What is f of 3? Well, notice we have the rule for f of x here. To find the output of f, if we give it an input of x, this tells us to take our input, square it, and add 3 to it. So that's exactly what we're going to do here. We're going to take that 3, that's our input, square it, and add 3 to it. And then, of course, that can be simplified. 9 plus 3 is 12. Okay, easy enough. F of a. Same deal. This rule tells us if we want to find f of any input, we take that input, we square it, and we add 3. So here we'll take our input, which is whatever's inside the parentheses. It's a this time. We're going to square it and add 3 to it. Now there's not much more we can do to this in terms of simplifying because we don't know what a is. So that's how we would leave it. Okay, turning our attention to this one. Notice our input is a plus h. Same rule applies. Take your input, whatever shows up inside the parentheses, square it, and add 3. So we take our input, a plus h, all of that is input, square all of it, and add 3. Here again, there's not a whole lot you can do to simplify things. I suppose we could expand it if you want to. That's just the square of a binomial, so it's a squared plus twice their product, plus the last guy squared, and then don't forget your plus 3 on the end. Either one of those is probably fine. I'll go ahead and put a box around the expanded form. What about f of x plus h? This is where a lot of folks get confused sometimes, but remember, it's the exact same process. This rule tells you if you have some sort of input, to find the output, square the input and add 3. Our input this time is everything inside the parentheses. So I take my input, x plus h this time. I square it, and I add 3. It's really no different than the previous problem. This x and this x are different x's, right? This is just a placeholder for whatever the input is. We could have written this as f of z equals z squared plus 3, or f of k equals k squared plus 3. This x has no relation to this x. What this does tell us is take your input, square it, and add 3, and that's exactly what we did. Here again, if you want to expand it, that's fine. If not, that's actually probably okay too. It's certainly shorter than the expanded form. Now, what about this one? We put a couple ideas together here. Well, f of all of this, here again, all of this is our input. Square it and add 3 to it. If I'm just looking at this piece, I would have x plus delta x, that quantity squared, plus 3. But that's just this. I have to subtract from that, let me put brackets around it, whatever f of x is. Well, what is f of x? Well, it's right there, right? Or equivalently, you could plug in whatever's in this parenthesis here, square it and add 3. Either way, you get the same thing. You're subtracting x squared plus 3. Now be careful here. You're subtracting f of x. All of f of x. All of this is f of x. If you don't put those brackets, you're going to lose a distributed negative. So be careful about that. And then, of course, all of this is over a delta x. Okay? This, of course, can be simplified quite a bit. So let's go ahead and do that. In the numerator, we can expand things out, right? We could square x plus delta x to get x squared, first guy squared, plus twice the product of those two things, so 2 times x times this delta x, again thinking of delta x as a single variable there, plus the last guy squared, so delta x squared. Okay, we still have a plus 3, and if we distribute the negative, we have a minus x squared and a minus 3. Okay, so that's the numerator. Of course, all of this is over our delta x. The numerator, however, cleans up a little bit, doesn't it? We've got an x squared up here, but then also we have a negative x squared. Those cancel. We have a positive 3, and we also have a negative 3. Those cancel. That's wonderful, because now look what we have left. 2x times this delta x variable plus this delta x variable squared, all of that over a delta x. Notice all those delta x's. As long as we're assured that delta x is not 0, and we didn't say that explicitly in the problem, but let's make that assumption at this point right now. As long as we're assured that delta x is not 0, and so this is defined, notice I've got enough delta x's up top here, I can pull that out as a factor and then cancel it with the one below. So delta x times 2x to produce this term, plus delta x times what to produce this? Well, it looks like we need another delta x. And then all of that is over delta x. Again, if delta x is not 0, I can cancel those two things and simply get 2x plus delta x. Okay, so as far as the evaluation of functions is concerned, that piece of this problem was pretty much over when we got from here to here. We just took what was inside the parentheses and squared it and added 3 to produce this. We did the same thing over here to produce this, and then there was some simplification. But again, you're going to see this particular expression a lot in calculus, so it doesn't hurt to see that here. Okay, so that's my answer to that one. Okay, now for example 2, let's look at the exact same expressions, but for a different function. Namely, f of x equals 2x over x plus 1. Okay, so to find f of 3 for this function, here again, there's my input. What does this rule tell me to do? It tells me to create the fraction that consists of twice the input over one more than the input. So this would be twice the input over one more than the input. Well, that's just 6 over 4, or reduced 3/2. Okay. What about f of a? Here again, the rule that we see here tells us to create the fraction consisting of twice the input over one more than the input. So this would be twice the input, 2a, over one more than the input, which would be a plus 1. Again, there's not much you can do with that since we don't know what the value of a is. So that is the simplified form. Down here, same deal. Twice the input is what's inside the parentheses here. Twice the input. Don't forget you have to put the parentheses there, otherwise you'll lose the distributed 2, over one more than the input. A plus h plus 1. The parentheses down here are technically optional. You can take them off in the simplified form, but it never hurts to put them in when you're making a substitution like that. If you want to clean it up by expanding it, you can. That'd be 2a plus 2h over a plus h plus 1. Okay, and there we go for that one. Here is, again, you have f of x plus h. X plus h is the input. This rule tells me to take twice the input over one more than the input. And remember, this x here is not the same as this x. Okay, this is just a stand-in for whatever the input happens to be. Here the input is x plus h. So twice the input over the input plus 1. Again, almost identical to the previous one. We just have an x thrown in. Don't let that throw you off. Again, expanding it, it'd be 2x plus 2h, all of that over x plus h plus 1, as the parentheses are no longer needed in the denominator. Last one. This one might take a little more work. Let's see. F of x plus delta x. X plus delta x is our input. I'm going to take twice the input over 1 added to the input. So that's going to be 2 times x plus delta x over x plus delta x plus 1. But that's just this piece. Maybe put brackets around it. Minus this piece, f of x. What is f of x? Well, it's given right here. Or you can look at its input and say, what's twice the input over 1 more than the input? Either way, you're going to get 2x over x plus 1. Again, that's just this piece. All of this is sitting over an extra delta x. So the evaluation of the individual functions that appear in this expression is done. We do want to simplify this, and that's going to take a little more work. So since we're running out of room here in the corner, let's take this up here. You've got a difference of two fractions over yet another value. It would be nice if we had a single fraction up top, so that when we divided by delta x here, we could simply multiply by the reciprocal of delta x instead. So to that end, to try to get this as a single fraction, we're looking at the difference of two rational expressions. We'll need common denominators, won't we? And looking at the denominators, x plus delta x plus 1, right? We can remove the parentheses on it just like we did up here. That's already essentially in factored form. It's a single trinomial there. And then we have x plus 1 over here. So this denominator is missing this factor, and this denominator is missing this factor. So let's rewrite this. 2 times x plus delta x over that x plus delta x plus 1 factor. We're missing an x plus 1 factor, so let's put it in top and bottom. So we're really just multiplying by a well-chosen value of 1 and not changing the overall expression. Minus this fraction, 2x over x plus 1. And again, this denominator is missing all of this, so let's put that in. X plus delta x plus 1. Again, over itself. So we're really just, again, multiplying by a well-chosen value of 1, not affecting anything in terms of its value. Now we've got common denominators, so now we can put those two things together. We've got a 2 times x plus delta x times x plus 1 from here, minus a 2x times x plus delta x plus 1 from here, all of that over the common x plus delta x plus 1 times x plus 1. Okay? Now, if we try to simplify this, we could, I guess, expand the top. That's going to give us, let's see, this product here would be x squared plus the inner product, x delta x, plus the outer product of x, plus the product of the two last terms, which is 1 times delta x. All of those terms are being multiplied by 2 here. So I'll just put it like this. Over here we have minus 2 times an x squared, distributing that x, plus x times delta x, and finally plus x, all of that over the common denominator. Now you may be wondering, why didn't I put the 2 in on all 3 of those terms? Well, look, there's a 2 here, there's also a 2 here. That 2 could be factored out, which is going to keep my terms a little bit nicer. So x squared plus x times delta x plus an x plus a delta x, and then minus an x squared minus an x delta x and minus an x, right? Factoring that 2 out of everything, and then over that same common denominator. So let's see if we can squeeze it in here at the bottom. Okay, and now looking at the top, the numerator, does anything nice happen? Sure does. We got an x squared minus an x squared. Those drop off. We have an x and a minus x that drops off. We even have a plus x delta x and a minus x delta x that drops off. The only thing we're left with up top here is a delta x times 2. So that's 2 times delta x. All of that over. X plus delta x plus 1 times x plus 1. Okay? Now, we've got to be a little bit careful here. There's a slight error. I said this was equal to this whole string of things, but no, I'm missing something, aren't I? I'm missing my division by delta x. So there's technically a division by delta x here, here, here again. But if you're dividing by delta x, isn't that the same thing as multiplying by the reciprocal of delta x? So rather than try to squeeze it under here, couldn't I just write times 1 over delta x, which would just put another delta x here and a delta x here? Look what happens. Delta x cancels. Again, under the assumption that delta x is not 0, it would cancel, and we're left with 2 over the product of x plus delta x plus 1 and x plus 1. And it's not going to get much tighter than that. So a lot of algebra in that one. Again, in terms of evaluating functions, the key step was getting from here to here and from here to here. The rest was just simplifying, but it's simplifications that you'll see again once you get to calculus, because this is a very common expression in that subject. Okay, it's called the difference quotient. All right, so that's 2 examples of evaluating functions.